back, scientists. This week we are talking about the conservation of resources. So how can we make sure that we're not using more things than we really should? Those are things such as water. Are we brushing our teeth and turning off the faucet in between brushing, or are we leaving the water running the whole time? Do we refill water bottles, or do we purchase water every single time that we need it? So this lesson is talking about what are ways, or how can we make sure that we're not using too much of any one item, or what are some ways that we can use an item more than one time. So here's our anchor chart. As we can see in the middle, it says we, and it's got a heart that looks like the earth, and then it says earth. So we love earth. So starting from the top left corner, let's make our way around. So saving water, and that's what the video that you'll watch later on is talking about, the process of cleaning water and what a difficult task that is. So part of the reason why it's important to save water is because the less water that we're just throwing away and not using properly, the less has to go through filtration, and therefore the less energy that we consume to clean the water properly. So one thing you could do is, when you're showering, if you turn off the shower while you're showering, while you're scrubbing up and stuff, that's a way to keep unnecessary wastewater from going down the drain. Then we see rescue animals, so making sure that we are adopting and rescuing pets instead of just constantly getting puppies and new pets. We want to keep the pet population from being too many. Obviously, next, don't pollute, don't throw your trash on the ground, make sure to use proper recycling and trash bins. Planting trees and flowers is how we clean the air, and it makes things look really nice, and also the roots can end up filtering and cleaning some of the soil. Reduce, we see in red. That just means don't consume any more than you need to. If you don't need it, wait until you do need it. Reuse, that's reusing something more than once. If you get a plastic bottle of water from the store, throughout the day, if you can, refill that. Use it a couple times before putting it in the recycle bin. Riding a bike, that means ride a bike instead of driving a car if you can, to save using resources like fuel and stopping exhaust levels from cars being too much, and just making air quality better. To go along with that, walk more. If you can walk somewhere, if it's not too far, parking lot, that sort of thing, go ahead and take a walk. Recycling, making sure things get put in the recycle area if they're recyclable instead of in the trash. Turning off the TV is an electricity situation, just making sure that if you're not using the television, turn it off. It doesn't need to run all the time. And lastly, making sure that we're cleaning up after ourselves, because a clean planet is going to be a better planet both for us and for the future generations.
It's time for vocabulary.
Natural resources are resources that can be found in nature and are used by people, such as sunlight, air, water, plants, and animals. We have two types of resources. The first is renewable resources. Resources such as wood, water, or plants that can be replenished naturally over time. The other type of resource are non-renewable resources. Resources such as fossil fuels that cannot be replaced after they are used. So fossil fuels are like the oil that comes from the earth, natural gas that comes from the earth. Other things that are non-renewable include like gems and stones, so diamonds, rubies, all that stuff takes so long to reproduce or to create again naturally in nature that it wouldn't happen in our lifetime. So if we use all that stuff right now, we won't have any more in our lifetime, or possibly the next generation wouldn't have those resources. Again, fossil fuels, fuels such as oil, coal, or natural gas that are formed in the earth from plant or animal remains. These things are considered non-renewable. Recycle. Recycling means using materials that have already been used to make new things. And the larger point of all this is conservation, which is the preservation and careful management of the environment and natural resources. So making sure we're doing our best to not use more than we need to, and that we're making sure to keep the planet clean and enjoyable for generations to come. Cleaning water is a process, and if we can limit the amount that we're just flushing down the drain or wasting, we can actually reduce the amount of energy that we have to use at these plants that clean our water.
It starts with a flush. Wastewater from 700,000 homes and businesses flows through sewers to the local sanitation plant.
Prior to recycling, the Orange County Sanitation District would treat the wastewater to a high level and discharge it into the ocean at a depth of 200 feet, 5 miles offshore.
The plant's methods are the same and include scraping to remove solid objects and 2 organic filtration processes that remove 90% of impurities. But instead of dumping treated sewage at sea, now they pump it to the Fountain Valley Treatment Plant, where scientists are trialing the new technology.
Each day we provide 265 million liters of highly treated wastewater for recycling. That's the same as if we were to fill up a large baseball stadium with water every day.
The scientists face a major challenge, turning liquid sewage into safe drinking water. The answer? 2 special filtration systems. First, fibers filter out particles bigger than 0.2 microns, 1/300th as thick as a human hair.
As you can see, there's all sorts of these tiny plastic straws, and these are the fibers, and there's actually over 15,000 of these fibers. And you can see they're very, very tiny, as if they're a tiny straw. And the process there, again, with this straw, is that if you were to pinch the bottom of the straw and suck on the straw, the water would go through the sides of the membrane and then out the top.
The water still teems with dangerous microbes. The next filter has to stop microscopic bugs, but let water molecules through. The answer is an ingenious process called reverse osmosis.
We can see through this vessel what happens is the water would come in the end of the vessel and then come through, be forced under high pressure between the sheets of plastic, then be collected in this center tube and come out the end as purified water.
This is how it works. Water molecules are tiny compared to viruses and bacteria. If a water molecule was the size of a tennis ball, viruses would be as big as trucks, and bacteria would be like buildings. A special plastic membrane peppered with microscopic holes exploits this size difference. It keeps the bad guys out, but lets water molecules pass. As a final precaution, ultraviolet rays zap the purified water, exterminating any rogue bugs by scrambling their DNA.
The water that's produced here is extremely safe. We pull samples on daily, weekly basis. We actually have over 2,000 compounds that we have to test for as a part of our discharge permit to satisfy the regulators that this water indeed is safe. This water is as pure a water as you're going to find. In fact, in a lot of cases, it's purer than even mountain spring water. Boy, that water tastes great. That's the best tasting water I've had in a long time.
Marcus enjoys his own product, but he has a dilemma. At this stage, the average person would say it's tasteless. To acquire a pleasing taste, the water travels 13 miles inland to be piped deep underground. There, it soaks up the natural minerals that make water taste like water. Marcus and his team are working on easier ways to add flavor. In future cities like Ecopolis, that would mean recycled water could be piped from the plant straight into people's homes. Today, 145,000 Orange County families already drink and wash with water recycled from sewage. That system uses just half the energy it takes to pump fresh water from the north.
I think right now we do a very, very poor job individually and collectively in our use of water. It's a very, very precious resource. It's a limited resource, and we have to do everything that we can in the future to minimize its use.
But how much carbon will recycling water save? And will it be beaten by this revolutionary dung-based power source? Dan Kamen is on a mission, assessing 4 new technologies that could slash carbon emissions in Ecopolis, megacity of the future. But he can only choose one. The carbon counters have analyzed how much carbon would be saved if Ecopolis recycled all its sewage. The result is a surprise. The megacity's carbon footprint would shrink only 12%, a fraction of the savings from urban farming, but more than acoustic refrigeration.
It still requires a lot of energy to run the pumps and to run the generators, and that means that just keeping the water quality the same is going to require a larger and larger energy and hence carbon footprint.
Kamen has time to make up his mind. And before he votes, there's one final idea to explore.
So let's do our best to recycle, conserve resources, and use things more than one time as many times as we can. Lanfear out. Our exit ticket. Which of the following is not an example of a way that students can conserve resources? A. Turning off the lights when leaving a room. B. Throw away plastic containers after using them. C. Recycle aluminum cans. Or D. Clean and reuse the glass jars.